For example, if somebody give you, let's say y equal to ex and the norm of x cubed. Let's say differentiate. See? So you see you got two functions here. Let's say, okay, let's just say this is x squared, ex squared. And this multiplication. So here you got the product of the two functions, the e and the log. Just say the e in it and the log. Okay. So before, if we was okay, if you had like something like this, y equal to e x cubed, and they say differentiate, this is easy because you don't have a product of the two functions. But here you have the e power sum, means this is the first function, and this is another function. That's what we say this is a product. We have to means the product of the two functions. So we have to use a product rule. Do you understand on that? So this is f and this is g. We call it f and g. So we want to differentiate f and g. But if it was, let's say, for example, if the question was, let's say, y equal to e power x cubed, they say differentiate. This is easy because I was going to say dy dx equal, if I differentiate x cubed, it's going to give me 3x squared. Do you agree with me? And then you write exactly the way how it is. E x. In other way, if somebody give me y equal to e power g of x, they say differentiate. What I want to do when you differentiate y, you get dy. But here there's an x, that's what say dy over dx equal. What you do, differentiate anything which is on top here. When you differentiate g of x, you're going to get g prime. So we're going to take this right behind e. When you differentiate g of x, it's going to give you g prime of x, and then write exactly what you have here, e g of x. This is why right here, they give me e, y, e, x, or q. What I did, I only differentiate whatever is on top, and then when you differentiate x cubed, it's going to give you 3x squared, which I wrote here behind e, which is this one here, and then I wrote exactly what I had here, which is e x cubed. Do you understand? Or should I say again?
No, it's fine. Understand.
It's okay. Okay, perfect. So what I'm going to do now, so for this case, you see, you don't have one thing, you got two things together. So we don't solve like this because if you say, oh, how if I start with this, what about this one now? So which one should you take? That's why we have to apply product rule. Now, how we going to solve that? So we're going to say now, so now we're going to say, so if we have a two function, this is what you say, okay, f, okay, just list the face and then you're going to write. I'm not going to erase, and then you're going to write. So now you got f face function times the second, so you say f times g. When we differentiate these two things, we just simply say, put the second one constant. See this is the second one? What is a constant? When you say constant, means do not change it. Write the way how it is, and then differentiate the first one. When you differentiate f, you're going to get f dot. And because there's a multiplication here, say plus, and then just flip whatever, everything you did here, just flip. So now it's going to be f, and now g is the one which is going to have it done. I can say it again. Should I say again quickly?
Nope. No need.
All right. So now we come. Huh?
No need.
No problem. No problem. No problem. I like that. No need for me to explain again. Maybe I should put more light. I feel like maybe the light is not enough. Let me see. Is it better now? Or like that is better?
Yeah, I don't see the difference. It's fine. We can continue.
Or you don't see no difference?
Mm-mm.
Uh, all right. So then we say, so now we say here, right? So we're going to say now, well, whew, this light is going to damage my eyes. Okay, let me just change that color. Okay, so now we're going to say now, for this case here, what we're going to say, the second one must be constant. So if you differentiate y, you get the y.
My prime.
Y. And here there's an x, you say over dx. Equal, the second one must be constant. So ln x cubed is constant. I'm not doing anything with the second one. And then I'm going to differentiate the first one, which is e x squared. There's a plus here, I must plus. We switch the passes now. So now, what is going to be constant? Now, this is going to be constant, and then we differentiate. It's like, you know what I'm saying? Because this was constant, always second one, start with the constant. Put the second one constant, differentiate the first one. Now, the first one is going to be constant now, which is this, and then we're going to differentiate the second one. So for that, we say dy dx equal to, so this is a constant, so we write away how it is. Now, when you differentiate e, what do we do? We say, oh, when you differentiate e, I'm not bothered with anything, I just have to differentiate what is on top. When I differentiate x squared, what do I get? 2x.
X.
So the 2x is going to come to the back here. I'm going to put it to the back. And then write away how it is, which is e x squared. Simple like that. Plus. Now, ex is constant, so now I'm not going to bother with it. I only look at this one. Ex is constant, ex. But now, let's come to the ln x cubed. Nosi, maybe she might be forgot how to differentiate. Now, I think so.
You think so?
So what we're going to do now, I'm going to help with the first one, the second one to see if you can remember. When you have a ln of a function, and then we want to differentiate, you know this means differentiate, right? We differentiate, what we do, we say, take this function, all the function, differentiate it, which is going to be f dash, and then over exactly your function that you have. So for that being said, here, I'm going to look at my function right here, and then we're going to have to differentiate that one, okay? So when you differentiate x cubed, is we write online. When you differentiate x cubed, is going to be 3x squared. We over 1 here, x cubed, and the ln falls away. The ln is going to be gone. You remember that? Oh, you forgot. You remember that?
I remember that.
No problem. So then what we're going to do right now, we say, okay, well, x cubed and x squared. So 2x go, 2x go. So it's like 3 over x. You see, that's going to be 3 over x. So then we're going to say dy dx. We found out.
So now I'm not going to see because now your board only ends at that part.
Say again?
I'm not going to see what you're going to write down now because your board ends at this part. On the part that we just did.
Are you going to write here? Are you going to see what I'm going to write here? Or you want to see?
No. Nothing. Yeah. Better. Yeah.
Wait. I see. I see. Okay, wait, just a minute. I know what. Can you see?
Yes, I can now.
All right. So then we're going to say now, so this will be 3 over x now. So then we say for that case, so this is like 3 over x. So here on the left, means we got two groups here, this and this. And here we have a plus. So we can take something common here. What is that common? From this group and this group, what is that common? We have a
I think we made a mistake then, because ex squared was supposed to stay constant, but we just said ex.
Oh, thank you so much. Thank you so much. And thank you for identifying what I said. This must be ex squared and ex. Thank you so much. Thank you. Now put it down. Thank you so much. That means a lot. Like you see how I make mistakes. You're doing very good. I'm so proud of you. So now we can say we got this group and this one right here. What we have in common?
It's ex squared.
So we're going to take this ex squared out, and then we're going to write everything inside. What we left here? 2x ln x cubed. But I'd rather write 2x first. 2x first, and then ln of x cubed is a good way.
Yeah.
Okay. With plus on the right hand side, we left on the left 3 over x. And that's going to be the last part. Easy like that. So if you want to write, you can write, or you can rewatch the video. What do you want? Whatever.
I'm gonna do this one without the solution, so you can erase everything, and then I'm gonna do it myself, and then I'm gonna send you the answer.
Oh my God, I would be so proud of you.
I'm gonna try. Hey?
I know you can do it. I know you can do it. So now we're going to rank this one, and then we're going to go for the other product. Okay. All right. So let's examine the product rule, and then I think we can do those questions in exam. Oh, quotient. Let me teach you quotient. Let me do quotient. Let's go for quotient. So we only do product rule if you have a two function and they multiply. There's a multiplication between them. You know, okay, I think it's later when you finish section, I'll talk about the headache things. About it. Okay, I don't want to mess up the station, so this has nothing to do with this. Okay. You know, at some point I thought I was the only one who felt that type of way. Cause me, I got like, I don't know, a couple times. And then but I know how to treat it, like you can get worse. Okay, cool. Now, so sometimes they give you something like this. Let's say they give you y equal to, let's say, non oh no. I say I want to explain to quotient rule. Quotient rule. So for product, let me catch again. Product, we say F times G. When we differentiate, we write the second one constant. Remember, the second one must be constant, and then we differentiate the first one. And then you plus, you switch them. You say, okay, now it's going to be F and G dash. Now the second is going to be basically constant, and differentiate the second one. Okay.
Okay.
So you're there?
I just want to write this rule down.
No
This is a product rule. So F
product rule. Product rule. Product rule.
Oh, good. Yeah, we can continue.
You got it?
Yes, got it.
Okay, no problem. Okay, cool. Now, so sometimes, not all the time they're going to give you multiplication of two functions. Maybe it's going to be division. So the easy way to remember, just say the second one must be constant fixed. So for division, let's say somebody give you y, y equal to, let's say,
Product rule.
huh?
Doesn't look like a product rule.
It does not look, because when you say product, means it's multiplication. So for this case, no, see, right? This is quotient rule. Is quotient. Quotient. Oh, you see, I said product here. This one, quotient. Quotient means division. Quotient. Ah, I forgot the spellings. Don't be mad at me. Right?
QU.
It's QU. Yeah, I think so. Yes. Don't get mad at me if I misspell. I've been misspelled since when I was a baby. This one, I never get it Quotient. So quotient rule. So quotient means division. Like you got that and this one. So the rules almost very similar how you do. You say, okay, so dy dx. So we're gonna call this, let's say f, and this we're gonna call what? G. So if I take f over g and then I differentiate, this is gonna give me, okay, now let's play the same game. How we say? Always, which one is constant phase? The phase of the second. Which is the constant phase?
The second function.
So G is constant, and then what happened to F? We differentiate F. So the only difference here, you don't say plus, you say minus. So it's going to be minus. Now you switch this. It's going to be what? F constant and then G dash. But the only thing come extra. Look, Nosi. Look at it. Only one thing came extra. You divide and then you square the denominator. Mean the second one is squared at the bottom. That's all. So everything the same here on top. You put minus and then take this the second one, square at the bottom. That's all. Okay. Or you can write if you want.
Yeah, got it.
You got it? Can I continue? All right, cool. So now let's go and let's play now. So we're going to say, okay, let's play. So this is going to be y when you differentiate, what you're going to get? When you differentiate y. I'm going to raise this, right? I'll raise this now because you're on the phone. So I have a space. Now, when you differentiate y, it's going to be dy over dx because here is x. Equal. What is a constant phase? The second one, right?
The second function.
The second one. So it will be long. X power 4. And then what do we differentiate?
We differentiate the x squared. The square root of x.
The top one. So we're going to say now differentiate the top one, which is square root of x. Plus or minus here?
Minus.
We're going to minus. Now we switch the steps. This is going to be constant now. And then we're going to differentiate that. And then what we do? We divide by square of the denominator, which is this. So we're going to say ln x power 4. But what we do? We square. That's all. Now let's start to simplify now. Let me show you something very, very important, Nosimilo. Okay? Look, apart from this, if somebody say differentiate square root of x, how you do this? We say before, I want to show you the short way, and then I want to show you shortcuts. So in exam, you don't waste a lot of time to start to do the long way. So what you do, look, I have to write this as a power. So this is going to be what? It's going to be differentiate x power half. That's the first step. And then what we do, since it's in power, we can differentiate. We take a half to the back, it's going to be 1 times a half, it's going to be a half. And then I write the way how it is, x is just x, and then I take whatever is on top, which is positive half, minus 1. Positive half minus 1 is going to be negative a half. But hey, I cannot live like that. So this is going to become, I'm going to have to take to the bottom. Even though I finished differentiating, that's why I did not write this one now in the next step, because I've done that differentiation by taking back the minus power. That's why I did not write dx anymore. Now I'm going to say now this I'm done, but I'm not going to write with the negative power. That's not okay. So I'm going to take this to the top. It's going to be a half. And this is going to come to the top. It's going to be positive what? course, with a half.
Okay. So does that mean I can skip that part and only put in 1/2?
I'm gonna show you because sometimes it becomes bigger the easy way. And then you say finally it's gonna be a half, but when you say x a half mean what? Square root of x.
Square root.
So do you understand this, guys?
Yeah.
You understand, right? Now let me show you the short way of doing it. So you always want a half, but only if it's square root. If it's cube, that's another story. I'm gonna show you other time. So now let's see the short way. I can erase, right? You're gonna rewatch. Okay, if you have, you can always rewatch the video. So now let's see the shortcut. So if someone says differentiate, so what I'm gonna do is say this same essay, I'm gonna write my half shortcut now. Remember that it must be half. And then we had the root. And write exactly this one. But it's not done for this case. You know what's not done? After that, make sure you differentiate the, you see this one here? And then write the answer here.
So it differentiates everything that is
inside the. And then when you differentiate 2x, what you're gonna get? When you differentiate x squared, 2x.
You gave me an answer.
God, I'm telling you. When you differentiate -2, what you got?
It's -2.
-2. And this is gonna be 0. So just like that. So that's the easy way, in a short way of differentiating what? Square root of anything. I'm gonna erase this, or you wanna write, or it's okay? And then
no, just a question now.
Okay.
Since you're saying I'm gonna differentiate what is inside the square root, on my final answer, do I put in the square root again or just leave it like that?
The square root is here already. Look. Because look, we know if we differentiate this, what do we get? It was 1/2 and then square root of x. You agree with me? You remember? But we were supposed to differentiate x. When you differentiate x, what you get 1. That's what I did right, because 2 square root of x times 1 equal to 2 square root of x. That's why I did not write this. But for this case, when you differentiate this, we get something out. We don't have to write another root now.
Oh, okay. Got it.
I can say it again if you want. Should I say again? Or is clear?
No, it's fine.
Is clear or is clear? Clear.
Clear.
Okay. No. All right. Very good. So that one is very clear. So sometimes they give you stuff like that. You don't want to waste a lot of time. Like 1/2. You put your root. You put your answer, and then next to it, you differentiate.
I see the exam is very close now, yo.
What is the time?
I think it's the 18th of May.
Okay, it's gonna be mock face, mock, and then it's all right, we go. But you know the topic which is challenge is only this and next assignment, the one which you just submitted. But 1 and 3 is easy. Those one I can just teach everyone like one day we finish. All of this. It's not hard, but it needed practice. That's why I did not want to. I didn't want to put this at last because you was gonna give up easily. You understand what I'm saying? Yeah. So that's why I started teaching you this, so you get used to things, to the things. Okay, now we go. So for this case here, we're gonna say dy dx equal. When you differentiate square root of x, what you got? 1. Okay, now give me the answer.
Okay, so the ln x over to the power 4 stays as it is.
Yes.
And then x square root of x is x 1/2. Or you want me to put in like the answer?
2 and then
Square root of x.
top or bottom?
bottom.
At the bottom, yes, so here. Very good. We're done. Minus minus. See, you save a lot of time. Otherwise, you're going to say, oh, what is this? No, that's an easy short one. Right square root of x is on top here. And make sure you must differentiate top and bottom. Can you see my number? When I draw my line here, you can see top is top, bottom is bottom. Don't mix them up. Because later, if you want to reciprocate, it's going to be hard for you if you write zigzag. Now let's go for that one. I want to see if Nosimilo should remember that. I want to see if she doesn't remember that. Talk to me now. What are we going to get there?
Okay, when you differentiate ln x to the power 4, it's going to be 4x cubed
4x cubed
to the power 3 over x to the power 4.
Over x power 4. I'm sorry, let me just switch off something. I don't know this other phone here is making noise. I'm sorry about that. Okay, let's switch off. Sorry about that.
No.
All right, cool. So then after that we say over ln x power 4 power 2. Don't do anything here, right? Don't do anything for the numerator. Don't worry about it. Don't do anything here. Don't say, oh, this will be ln x power 8. Nah, don't do that. You'll be wrong. Because this
And I was
like
thinking of saying that.
It's like, okay, if somebody give you, for example, x, y squared. Are you going to say x, y power 2? You can't, because this is for both. Means it must be x squared, y squared. But now you cannot say ln square x power 8. No. Don't do anything, leave the how it is, okay? Leave the how it is. All right, so what are we going to do then? What we're going to do then, I'm going to have to deal with the top one. How am I going to do with the top one? Look, let me show you this now. Look, if somebody give you 1 over a minus 3 over b. Fraction now. How you solve that? This one, I'm going to have to multiply this to the top. 1 times b equal to b. Minus minus. A times 3, 3a. And then when I finish, I multiply those 2. A times b equal to a, b. Normal fraction. I can say it again if you want.
Please.
Please, right?
Yeah, please say it again.
No problem. I can even say 1,000 times just to get this, okay? So this is just a normal fraction. It's like somebody give you y over t minus k over x. So if it's plus or minus here, if it's plus minus any sign, what you do, make sure you start with that, you multiply that. Y times s, ys. Whichever sign is here, you write. So now it's minus or plus, you write plus. Now you go that one, this side. T times k, tk. And then you over, you multiply this 2. T times s, yes.
Okay, yeah, got it. This is a fraction group.
Let me know when you're done.
I'm done.
Okay. All right, cool. So now we say if you can look this is a fraction here. Do not look how big it looks. It's like a over b minus a over b. Do you agree with me? Do you agree with me first? Don't look how big it looks, no? A over b minus a over b. Do you agree with me?
Yes, I do.
So what we're going to do, we're going to solve like how we solve there. So we can have a common denominator. There were 2 denominators, but I will make it a common denominator. Now, so how are we going to do that? We say, well,
But first, is it possible to simplify the 4x to the power 3 over x over 4?
Thank you.
To the power 4.
So this is going to be 4 by x. And thank you so much. It's going to be 4 by x. So we're going to remove this. I'm going to remove it, right? Because we're going to rewatch it. So it's 4 by x. Thank you. 4 by x. So 3x and it's going to be 4 by x. It's actually make it easy now. So this is going to be 4 by x. And I appreciate it. So what we're going to do, I'm going to say x times that. So that's going to become, x is going to come here, right? It's going to be, minus is going to be x ln x power 4 times 1. You just said x ln x power 4. 1 is going to disappear because anything comes on equal to that. I can say it again. No? Okay.
Hello.
Hello? If you multiply, you just put these together. So now, on top, we have it like this is on top. Ln x power 4. Ln x times power 4 times 1 equal to ln x power 4. Times x is going to be x ln x power 4. Ln x times 4 times 1, ln x power 4. Times x because we multiply that way. X ln x power 4. X ln x power 4.
Okay.
Minus, just like here, minus, but it was plus, you say plus. Now you take this, you multiply by that. Now you tell me what you're going to get here when you multiply this again.
I think the square roots will cancel each other and then you'll be left with one of those.
So square root is going to cancel?
Left with 2.
It's going to be?
2.
But there's a 4 here. So it's going to be 2 times 4 equal to 8. Okay, listen. Nothing, look. Let's go step by step. What do you multiply here? You say square root of x times square root of x. What you going to get?
Square root of x times square root of x.
Yes.
It's x.
Is x. So these two, they're going to give you x. And what about number? Because everything you must multiply by everything. So it's going to be x, and there's something else in here you left.
Should I just leave it as it is, or I can just say 2x?
But you must take everything. You don't have to take one part. Everything here, you multiply by everything there.
Okay, 2 times 4 is 8.
So it's going to be 8x. Are you agree with me?
Yes.
Yeah, you just do what you see. That's all. You say, okay, so this here is going to give us 8x. And then after, remember, you must multiply the denominator.
Yes.
What is the denominator? 2 square root of x times x. And then how is it going to give us? 2x square root of x. 2x square root of x. You agree with me?
Yeah.
But all this stuff is over what? You're not going to see here, right? Can you see here if I write?
No. No.
Can you see the one I wrote here, what I wrote here?
Yes, I see.
So we over what? Ln x power 4 what? Square. I'm going to erase this, yeah? I'll erase so we can finish it.
Yeah.
Okay, cool. So then, look, we go to the fraction, normal fraction. If somebody give you A over B over C, before, do you have a calculator with you or you don't have a calculator? No?
I do have one.
Okay. If somebody give you 2 over 5 You must put in a bracket exactly, right, over 3. I want you to guess. What is going to be the answer there? Oh, no, 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 no. Don't put the calculator. No, see? Don't put the calculator. 2 over 3 or 2 over 5 over 3. You know what you do in math, right? If you have a fraction over number, this number is going to come to the bottom. So this is going to be 2 over 3 times 5 equals 15.
Oh, really?
Yes, you should know that. Only if you have a fraction over number, the number goes to the bottom. So if I have A, B over C, how is it going to become final?
A over BC.
A over BC. And you can verify this one. Put in a calculator. Make sure you put the bracket on top, okay? Put the bracket out.
Oh, A over B over C. Okay.
Okay. You good to go?
Mm.
I'm sorry. I'll let you talk while you eat. Okay. Now, so if you only remember, okay, the only thing you should remember, right? Don't just remember solving. If I have a fraction over number, or fraction over one variable, they denote the one at the bottom is going to go to the denominator. But sometimes you have something like this. Let's say x over ab. This is a different game now.
Ah.
Look, yeah, it happened. So what you do, you take this, always the denominator, the bottom one, goes to here. So the only thing, this. For here is going to come here, but for here, this is like, it's like you flip the process. But, wait. Let me show you this one. Let me show you this in exam. Look. Let me show you how to remember. Let me show you to remember. Remember this. Let's say A, B. Just remember this. C. So this will be what? A, B, C. You agree with me?
Yeah.
So this went to the bottom. So now what you do, flip the same thing. If let's say for that, say C over AB. So where did C went to? It went to B. So this must go to C.
Okay, so now it's gonna be BC.
So what you need to remember only one, okay? Remember only one. So this is gonna come here. It's gonna become CB over A. You understand what I'm saying? So now, oh, you want to write some? Okay.
This one will go there. Okay, got it.
You got it?
Yes, got it.
Oh, sorry. Can I just tell my other guy there's a gum happening with the engineering stuff. So I think he has some problem. He was supposed to submit yesterday. He didn't submit some projects to the programming. So I want to tell him like, so that's here. Just a minute, sir. Oh, my phone problem is full now. I can't even send you out. I have to remove a lot of stuff now. Sorry about it. Okay, cool. Let's go. So okay. So now you know the game, right? It's easy. All you need to remember, for example, somebody give me x m over b. I'm going to do this. How this will become?
X over BM.
X over BM. So this is going to be X over BM because it's one. Okay, now let's flip now. Let's flip. X over AB.
It's going to be XB over A.
It's easy. So same here. So, and this is very good stuff here, since you understand. Easy. Easy. Okay. Let's go. So this one we had, let me rewrite again. It was dy over dx equal to x ln of x power 4 minus 8x over 2x square root of x. But all this stuff, it was over ln x power 4 square. Can't you get the picture there? It's like we got fraction over fraction, fraction over number. You know I say fraction over number? Because this is like a one thing, remember, right? Because this is like tell you, this is like A over B over C. Yes or no? Huh?
It's a yes.
Okay, cool. So we're gonna take this one right here. Where is it gonna go?
It's gonna go to 2x to the square
root
of x.
But you see how easy it is, but it can be very tough if you take it as a math. So you don't take it as a math, all you need to take as a small solving, like, oh, so this is like A over B over C. So this C is gonna come here. So then finally, this stuff is gonna be, woo, I can take x out if I want.
Yes, I can.
X out, ln x power 4 minus 8. Oh, Joanna, why you not take? Can you take x here? No, never take anything in front of ln. That's not, it's going to be seen. Never do that. You only take something behind scene. Behind ln, not all. Over. How this going to become now? Tell me how it's going to become right now. Talk to me now. To see if you understand.
I'm not even sure whether I should start with the ln or start with 2x, but anyways,
always ln put it in front. Or ln must be in front. Don't put it behind.
So ln must be in front.
Yes, it's like you. It's not good to say this word. Ln 3. Let's say ln 3 times 4. Don't write like this.
So it's gonna be 4 and then.
Because you confuse the marker, and you might confuse the set because you must say ln of 12, which is not. This is for ln of 3. Is a good way of writing. So for that case, how I'm going to write this? It's going to be 2x square root of x and then ln of 4, or ln of x power 4. X 4 power square. And that's going to be the last one, dy dx. Now let's go to the assignment. Let's take our assignment and then we solve it, okay? Oh, you don't have your phone with you, you say?
I don't have my phone.
Oh, you don't have? You don't have?
Just trying to think, what am I going to do? Let me just do a snip here.
Eh?
I just want to do the snip.
Because I'm thinking, I want us to solve that assignment. So you can see the option, how we get the answers.
Oh, okay.
So I can write and solve, but then no problem.
No, that's fine. And let me just go and get my phone and see how far it is, the battery.
Oh, it was charging. Do you have a load shedding there? Do you have a load shedding or you don't have a load shedding?
I don't know. I didn't check the schedule. I'll be back just now.
No problem, no problem.
I got it.
Okay, let me send you now, right?
Okay.
Okay, let me send you. Okay, let me send you the question. So how comes you say in the mines, or your partner live in the mining area, or how comes? Because it don't make sense. Like you're doing business management, but you live in a mining area.
My
or your
husband stays here.
okay, because you didn't connect to me. okay, okay, I see. Even one of my cousins also, he work in the mines. He did engineering stuff, so he did mining engineering. He work in mine. He work in the mines. So. It's a very good stuff. But me, I don't like to do mining because I don't want to stay one place. you see? But it's very interesting, because, yeah, it's very good.
Good for me.
Yeah. I like traveling, so I always like to move. Okay, let me send you the question.
You mean assignment too?
Yeah, I'm sending the question that I want to go through. But then did you submit this assignment?
I did.
The last one, assignment 4. Assignment 4, I don't know.
Yeah.
Okay, make sure, hey? I'll send you now. It's definitely tough to do. Okay. Okay, you got that one? Okay.
Yo.
Okay, let's start to the first one. The first one is way easy.
Okay.
Okay. You see with the Kia, right? I don't know if you know Kia Bay. We finished with everything. She's just waiting for you guys. because she was attending the whole last week, so we finished with everything. But why you do business management? Let me ask. I hope you don't mind. Why you do business management? Like, what
I don't
motivates you?
know.
The business, or you want to work in a business firm, or why?
I don't have reasons why I'm doing this degree. The only thing I want is to have a degree. But apart from that, I don't care what degree I get.
Are you serious?
Yes.
Nah, come on, Nosi. Oh no,
I'm
let's.
being honest with you. I'm already working and I just need a degree, any degree.
But that's not. It's okay, but it's not right. You face here, right? For this program that you're doing, the new program that you're doing now.
Mm.
Okay, well, I think we can do separate video because I don't want people sometimes to know you're.
Good. Let's do the questions.
we can talk later. But come on, it's not right. It really is not right. For it's not right. You can just have any
I've,
degree because now look, it's
I've
time
got a
now.
qualification for the work that I'm doing right now.
I know you got it, and I respect it. But it's about time and money and your resource, and you go through stuff that you know. Okay, let me just have it. I don't think it's right. In my opinion, I might be wrong. We're gonna talk
I
about.
need to have it for the next position that I need to go into.
But how if you do and then you finish that any degree and they say, this degree is You could.
No ways. It is in line with the company policy, so they can't say
Okay. Okay. So you don't just do any degree like what you say, as far as I'm here.
that. Okay, so you do a degree that is in the company policy. There are so many, but you have to choose one, obviously.
Oh, so you choose because it's one of those.
Mm.
But your statement say I'm just doing a degree just for have a degree. That's why I was just kind of surprised. Like you just doing it because hey, it's it's very strange. I got a lot of my friends that have a degrees. They can get a job. It's bad, hey. A lot of my friends. I've got
That's
a lot of my friends. What
that
they do, they
is
just get degree. Like I've got my two friends. One have a degree in BCom. He never had a job for 4 years now. He decided to do. There's this course you do for 1 year for teachings, and then you become a teacher.
yeah,
PC,
PGCE.
yeah, he does that.
PGCE. Mm.
Social worker, I know about 20 of them. They have an honors in social worker. They did that UNISA, UWC. They can get a job. I don't know. Yeah,
It
but
is
you know
so
me.
hard to get a job, hey? Even if you
Mm.
have a degree, honors or masters, nowadays it's so hard to get a job.
Yeah, it's hard. It's hard, yeah. But I don't know. I tell people like you can start your own stuff. Me, like I'm not a job looking type. Like I'm like that. Like I was raised or grew up in a situation where you create your own business, you do your own thing. So I'm not like, but it's sad sometimes. I got a lot of my friends. But I tell them like, I go like training social work. I tell them like, guys, listen. I mean, because of this computer science, math degree, computer science, honors, computer science, math also. So I tell them, look, I can help you to create a website, and then you have your website. Start a project. I even draft
Mm.
anything for them. I can help you like what you do, whatever, because I'm a street expertise. I can even take you help like maybe help people homeless or feeding program. And then you create your profile. Let's say you two, group yourself like three, 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 three. You create your profile, and then after that, you post on your website, whatever. And then you can ask a fund from the government or whatever, they're gonna help you. You've already create your own jobs or whatever, and you have helped your community, and you have
Mm.
maybe you're gonna create a job for the other social work. But they don't want, they say they just want money. I say, how you gonna get money?
Um,
There's no
it
job.
doesn't work like that. So if a degree doesn't work, you need to try some other things. Even selling.
Even
I
selling
used to
it.
sell Herbalife for some time.
They say they don't want. They say no. Me. Let me just keep on looking. They say so. A lot of them they have 5, 4 years no job now. So you gonna keep on looking. View that can help you. Like they don't want. They say they just look for job, and other one decided something. They decided to do masters, which is good. But these days, job is not guaranteed. You have to be creative. All right, let's decide. Let's go. So let's do this question first. The SFX said, man, me like this. Equal to E x power square minus 3x. Okay, now let's do that one. Easy. So if you have an E power function, how do you differentiate it? You remember that?
Yeah.
We differentiate. Okay, how we do this?
You differentiate what is in the top and then you say E and put
So
everything as it is.
F prime, you differentiate the one, and then we write exactly, which is E as a thing. And then here is going to be, yeah, we differentiate it. You understand? So now you're going to do the same thing here. I'm sorry. I'm small. Sorry about that. All right. So now we want to say, well, if I differentiate f of x, it's going to give me a prime, and then now do it for me. You tell me how we're going to do this one right now, Nos. Talk to me right now to see if you get this.
So it's going to be 2x minus 3.
Where are we going to write 2x minus 3?
Behind e, obviously. And then we're going
to 2x minus 3. And then after, we write exactly, which is e.
Yeah, as it is.
Easy. You see, that was part of the assignment tools.
How are we done?
Yeah, we're done already because they say differentiate. It was an assignment as well. Okay, let's go to question number. Question number FFX. Let me write this one. This question number. Okay, let me write please.
Oh yes. So the answer is C.
Yeah. Okay, now FX equal to EX over X. But now for this one here, look careful. Find the second derivative. So what then?
Ah.
Means
Yeah.
first and second time. Yeah, I love second derivative. Yes.
Okay.
Yes.
Hold on. So they are saying we must find the second derivative, meaning we must differentiate the first one and then differentiate what you got, or differentiate the answer.
Like
Oh, I'm not ready.
Okay, let's go. So what we're gonna say here, like second derivative. I love you. Okay, now we're gonna say now, which type of derivation this? Product or quotient or what?
Quotient.
Quotient. So we're gonna apply our rule. So we're gonna say f of x for the face derivative. So we can simply say this semi say if you have a so this is gonna be f and this is gonna be so now
Yes.
so the formula say you remember the formula? You say f over g when you derivate, we write the denominator constant and then you write your f minus we switch f prime g and then we divide by the square of the denominator. Do you remember that or not?
Hi, it seems like your prime.
It's okay. It's okay. I'll take it back. You just said I
no,
don't.
I remember, but it seems like your prime are sitting in the wrong ones.
Okay.
Because now it looks like that's a G prime.
Okay. Denominator constant. Denominator constant. Thanks.
Yes.
Differentiate the numerator. What is the numerator? F dash.
Yes,
Plus
like that. It's a minus.
Oh, and then we switch. This is going to be F and then G prime. And then we over denominator square. So now let's come here. So we're going to do so in exam, you don't want to waste a lot of time and just do straight. This is how you do. Denominator constant.
Yeah, and then differentiate EX, it's going to be EX. Ah, got it.
Thank you. Look, you're the only one who go down on straight away. Very good. I'm proud of you. Okay? You get EX. And then here
minus EX constant.
Is constant, and then we differentiate the denominator.
Which is 1.
Oh, no. Yeah, it's 1. Yeah, it's 1. Yes. You're right. But if you see, you do very slow if you think you get confused. Equal to over x squared. But EX times 1, what do we get? EX.
Yeah.
You can say EX. So this is the first derivative. But I can take EX out because EX is common, so I can say always simplify to simplest form. If you take out EX common, it's going to be EX x minus 1. And then over x squared. Do you agree with me?
So now we need to differentiate that.
It's a second derivative.
Oh my God. Please hold on. I just want to write this first.
No problem. It's okay.
I'm not ready. I'm not ready for the second derivative.
It's very easy. I'm telling you, it's easy, easy.
Are you sure? Okay, let's do it.
I promise you.
Because now we have a product coefficient. Quotient. God. Andikho ready kaloku.
I was about to Nosimilo.
No, I'm Zulu. I'm Zulu.
Because I see you say Andiko right. Ndiyafunda zinto. I'm learning this stuff, I was just learning, having a lot of books. I'm learning all the languages. Now I'm on Spanish right now.
Okay. Hi. Let's derive the.
Okay, now let's go.
Let's find the second derivative.
Okay, now let's go second derivative. So second derivative, I'm sorry about that. Second derivative, we say second derivative, same thing. What is the constant now? The denominator is constant. What is that denominator? Okay, you do for me so you're not gonna forget. Okay, what is the constant here?
Sorry?
Okay, this is a quotient, right? This is F and this is G. Now let's work together. How are we gonna start?
Yeah. So we're gonna say x squared, constant obviously.
And then we're gonna differentiate. Since it's bigger, you don't want to do everything by head, you're gonna confuse yourself. And I'm gonna differentiate my numerator. Are you with me? Step by step, right? Yeah. That's the best way. And then which sign?
Minus.
Minus. And then what we do, we switch it. This is gonna be constant, we differentiate there. So yeah. X minus 1, and then we're gonna differentiate what? X squared.
Which is 2, okay.
Then we're gonna, and then we over what? X power 4. Because x squared, x power 4.
Oh, yes. X
or should I say x squared? Okay, let me just do slowly.
Nah, it's fine.
Okay. Let me not upset you. So you say, oh, I want to write 4, he say 2.
It's okay, it's okay.
Okay. So we got that one x power 4, right? And then we say this is equal. So now, the only issue is here. Because here we know it's going to be 2x. So we're going to take this one here and deal with it. You understand? No? But remember, this is a product, like, it's something smaller, but it comes as a product rule. So let me take this and handle it to here now.
Okay.
Are you with this?
I just want to try it as well.
Okay.
X minus 1. Yeah, it is a product.
Okay. Okay, try. Let me see how you can try. You want to try a side? And then we do together and then give me the answer?
Okay, 7 minus 1. That's another lost guy. It's 1. Is it 1? Okay. The first step, since this is a product rule, so we're going to take the second function, which is your x minus 1 times ex.
Yeah. Times
and then
differentiating dx.
Ex, yes. Which is Ex anyways.
Yeah, which is Ex. So it's going to be Ex. But I think write it because, so that you don't make mistake. I would suggest you write D, okay. Write x minus 1 D of Ex plus. Let me see. Did you finish?
No, not yet. I only wrote the first step.
Okay. Do it. Continue.
Okay, what is common here? Yeah, I'm not sure if I'm correct, but can try.
Okay.
You want me to give you the final answer, or I need to go step by step?
Final answer, please.
My final answer is x e to the power x.
Okay, you got your final answer?
I got x
Now,
and then e
let's
to the power
let's
x.
do it together. So we're gonna say now, I'm gonna come and do a side and then I'll, okay, so we're gonna say second on constant, differentiate the first one. When you differentiate the first one, you say differentiate the first one. Plus for this case, because the product, now this is gonna be constant, and then we're gonna differentiate x minus 1, which is gonna give us 1.
Yeah.
Now,
That's
this is gonna be ex, x minus 1, because x is just ex, so you differentiate x minus 1, plus ex. But we can take out ex. Ex go out. When you take ex and ex, it's going to be x minus 1 plus 1.
yes, I got it.
1 equal to 0. So the answer is going to be x ex.
I got it.
Very good, Nos. So all this stuff here, I'm going to replace with x ex. Okay. If it's a multiple choice, you don't want to waste a lot of time, you do your stuff, but when you learn, like, you can write for fun. X ex. So this stuff here, I'm going to replace with x ex. X e power x. And this, when you differentiate, you get 2x.
Yeah.
All this stuff's going to be 2x. X squared, when you differentiate, you get 2x. So I can write 2x before. I have minus 2x.
Yeah.
So for that case now, so we want to say now, okay, let's do this, sorry. So we don't write dx anymore because we have already done the process. Means we have already differentiated. That's why we got this. So I don't have to write d no more.
Is that our final answer, or we can?
We need to put together. We need to put together. We need to put together. So now, anything common, we'll take it out. There's an x squared, no x squared. E of x, e of x. But we can take out x here. There's x, we can take it out. Okay? Okay, so since x and x is common, and e of x is common, so I'm going to say x and 1x is going to go, oh, x and x is going to go out, it's going to be ex is going to go out. 1x is going to go out. So let's write over that here. X squared minus 2 x minus 1 over x power 4. Do you agree with me?
Yeah.
Okay. Let me say something just a second. I want to take the question. Which question is first? Oh, yes. So what we say now, look. No, see? Oh, okay. So you want to write down? Okay, so
I'm trying to...
1x and 1x go, so this is going to be x3.
Oh, okay.
So then, ex, x squared, 2 times x, negative 12. Negative 2 times negative 1, positive 2. X cubed. Let's take in a memo then.
Just hold on. Let me take a picture.
Yeah. Check in the memo.
Let's check the memo. Yes.
Yes, you did it. I didn't do it. You're the one who did it. You did excellent. Very good.
We did it. Okay, I'm gonna try it again and do it on my own. Let me just say this is my number 3. And this is the second derivative. Okay. We can move to the next one. Oh, this is a large jump.
Okay, cool. You got it? Now, let's go to the next question.
Oh.
It's not hard. Or it's not hard?
No, it wasn't hard. It's just that you need to remember all the rules.
Yeah, you have to remember all of it. Let me show you something very interesting now. Okay, we wipe the board, and then we go to the next question. The only thing I want to do, sometimes when you do farming and go in the rural, I like farming. Like have some animals and stuff, I like that a lot. I do the animal, I like it a lot. I like it a lot. Or helping other people, you know, especially like people from the rural, you know, start some projects, maybe start some computer centers and help elders or people from the, you know, just equip them with the skills. Okay, let's go for the next one. This is the one which is the most interesting one. Okay. Okay, I'm going to send you again. These on here. Okay. Let's start with the second from the last. X of x equal to 14 plus 1 x. We have x plus 5. All right. Let's go. This is the most challenge. It's not tough, but for most of the students I deal with, they say, "Oh, it's challenge." Okay, let's go. So what we're gonna do? The rules are the same. Rules are the same. So I'm not gonna look like, "Oh, what's it?" No. Let me follow my rules. My rules tell me f prime. When I differentiate 14, what I'm gonna get?
0.
0. So 0. And then here, I'm gonna have to differentiate function. So I'm going to say if I differentiate whatever I have in front of the log, remember say if you have a lot of a function, what do we say? If you differentiate for the f prime means take whatever is in front of the log, differentiate. It will give us a prime. And then you over f of x. Everything which is here must differentiate. So we're going to apply the same rule here. The same rule says I'm going to have to differentiate everything in there. And then I write on top. And then we're going to have to over
the same
exactly what's there, which is x.
Is that a 3 or 5?
Oh, Let's see. It's level 5. I'm sorry. Thank you for correction. You're good with the accuracy. So how if I cancel this? No, you cannot cancel this and this because you must differentiate the one with time. Oh, let's cancel. Wait. This one here you must differentiate. You cannot cancel. Okay? You can't cancel. You cannot run away from this. Now, so we're going to take this aside and treat it as a quotient. And then we're going to come back here. So we're going to forget this one. Say, hey, we forgot you now. We're going to come back left. Now we go. Okay. So it's easy. You just have to remember the rules. Now we go. So if I differentiate x, square root of x, plus 5, this is going to be denominator constant. What is the denominator? Square root of
x
plus 5. And then, should I do straight away or should I show steps?
Sorry?
Should I do straight or should I show steps, or I can just do straight away?
Let's just do step by step for this one specifically.
Okay, so this denominator constant and the differentiate what? X.
Yeah.
Minus or plus?
Minus.
Because it's quotient minus. Now, this is going to be constant now, and then we put a differentiate this. And then after that, we'll go over square of the denominator. This one here is going to square. Any questions so far? Any questions right now? Everything's fine.
For now, I'm okay.
All right, so we're going to say this is equal. Let's start from here. Okay, this is going to be equal to. When you differentiate x, you get 1. So it's going to be 1 times x plus 5. It's going to be square root of x plus 5. Minus. X is x. When you differentiate x plus 5, I need one answer straight away. When you differentiate square root of x plus 5, I just need one answer shortcut.
The only part I remember about the square roots is just that we say half.
Okay, so it's going to be what? 1 over 2, and then?
Square roots of the same thing.
The same thing. Very good. And then what happened here? What are we going to get if we differentiate what is in here?
Oh, and then we differentiate what is inside. Then it's going to be 1.
1. So we don't have to write 1 because anything times 1 is that thing. So we don't have to write 1. So then,
yes.
So if you don't know that, you waste a lot of time. And there's no time. We got that, and then we over what?
X plus 5.
And this is going to cancel from the x plus 5. But hey, look, there's a problem here because this one I can say this over 1. So I need to put this as the one fraction.
Okay, are we just going to do the cross multiplication?
Yes. So square root of 5 times square root of 5 is going to give me x plus 5.
Hi.
This one, look. Square root of 5, x plus 5 plus times this time the same thing. Means the root is going to go.
Oh, yeah. Then we're going to be left with
x plus 5. But there's a 2, so it's going to be 2x plus 5.
Into x plus 5, yeah.
So this is going to become 2x plus 5. So this one we've done. Now we come 1 times x is x times 1, x. But with minus, we write minus x. Over. We multiply these two.
That's gonna be a 2.
2x plus 5. Do you understand or not?
Yeah.
And then we're going to have to over x plus 5. But hey, I know how to do this. I do remember. I got a fraction over one thing, a, b over c.
So we're going to take x plus 5 and put it into the 2.
Yes. Yeah, it's going to be 2x plus 5, right? Square root is going to come in here. But this also I can simplify this one. Don't talk. Before I do anything, I can simplify it. 2 times x, 2x. Minus x is x. 2 times 5 is 10. So it's going to be
10.
x 10. X plus 10.
Okay.
Should I replace them or it's okay?
Hold on, let me take a picture.
No problem.
Got it. We can continue.
Okay. So now what we're going to do is going to be 2 times x is 2x minus x is x. X plus 10.
So it's x plus 10.
Yes, x plus 10. And this top is going to come here. So it's going to be x times x plus 5. Okay. So we're going to put here 2 x plus 5. Is that clear?
Mm-hmm.
And this is going to go. Let me write so well. Let me write so well here. So it's going to come 2 So when we differentiate all of this, which is this, we're going to get there.
Please say that again.
Okay. Remember, we took this and then we say, let's deal with the question too.
Oh, yes. So when you differentiate that,
we get there. So this must come back to its position. So it's going to become x equal to x plus 10, 2, x plus 5, and the square root, x plus 5. And then we over. Now, if you want to do those canceling, you can do now. Because we have already differentiated. Over. What's this over?
X over
X
square root
plus.
of x.
Now you can cancel if you want. You accept it. So how you want to say now? This and that is going to cancel.
Oh, yes.
Acceptable.
Now I'm going to be left with x.
And where x is going to go now? Because it's going to be a over b over c.
Okay, so now it's going to be x plus 10 over 2x into...
No. Oh, my apologies. I'm sorry. You're right. Sorry. My apologies. I'm sorry. So what you say? How's it going to become? Where this x is going to go now? That was my question.
Next to 2 there on top.
Yes, done. So everything else is going to be the same. So we're going to say, well, this is equal to x plus 10, 2x, x plus 5. That's all. I think so. Let's see. Let's see. Oh, why I feel like it's wrong. Let's see. It's right. Check. Yeah.
Is it? I didn't even want to check. Oh, yes, it's correct.
Yes. All right, we got that one. You see that? Now let's go to the next one.
Yeah.
Let's go for the next one right now. I'm gonna erase this, right? Should I erase?
Don't erase it as that.
Okay.
Let's do not take it.
So it's more of the rules. Like if you forgot the rules, it's become very hard.
Okay, we can proceed. Yeah. I think I'm gonna attend tomorrow as well, but I'm gonna attend after 5 o'clock.
Okay, cool, no problem. Now let's go for the next question, which is way easy. All right. You know what I use? I use handy to clean this stuff because sometimes it doesn't want to clean. So I have to use handy. With handy clean so well because I try to use spirit, you know the spirit they use for I don't know how to call it. Like sanitizer, but it does not clean so well. Only handy gives it a great job. Okay, all right. Only one last question will be done on this exam. I think there's another one, but this could be. But now you understand differentiation is very important, this, eh? Very important. Like even if let's say you're done with this stuff, never stop because at some point it's gonna come through. It always comes in some stuff, and then it's gonna happen lots. Differentiation. All right. Let's check that question right there. The last question. Product rule 12x E6x. 12x E6x. Y equal to 12 x E6x. This is very easy. Which type of this? Is it quotient, product, or normal differentiation?
That's the product.
Product, because you got first one and second one, means I can say two groups. So I'm gonna say now dy dx equal the second one constant.
Yeah.
And then what we do?
Differentiate to 12x, which will be your 12.
It's gonna be 12. And then we plus, now this is gonna be constant. And then, yeah, we're gonna differentiate what? E6x. But we're gonna get there.
It's gonna be 6e.
6e.
6x.
Are we dividing and square or how we do?
No.
Wow. Wow.
The product.
Very good. I told you for calculating. Because the product.
Nah,
The product
I'm still on the right track.
So for that case, so we look anything which is common. What is that common in both groups?
It's a E6x, but is it possible to take 12 and put it behind this?
So we're gonna say 12 is constant number of x, and then we go for E6x. So here, what we're gonna be left with if we take E12 here? One.
Oh, plus.
Plus, because everything went out, so left with 1. With plus 12 E6x went out, so it's gonna be 6x.
Now I'm
Yeah.
lost.
So we're done with it. This one was way easy. Check the answer and then we'll be done. Let me see if you have other questions. Oh, we're done.
Okay. Are we done? I'm just gonna go back and tackle all these questions alone.
Yeah, I think we're done with it. Let me just see if we have other. No, I think we're done. Let me see. Let me see. Let me see. I won't have no more questions. This other stuff is something else.
No, it's okay. I will do some other questions tomorrow. For now, let me just go back to what we discussed today and see if I understand.
No problem. Do you feel like you learned some?
Yo, I've learned a lot.
No problem. But don't stop to practice it. Even if when you say you've done this topic is very, very important. It's going to help even for future. I promise you, it's very, very important. Very, very. And one thing about math, you can forget easily everything. It's very easy. No problem. So thank you so much for coming through, Nosimilo. I appreciate your time. Yeah, just get well soon. Get well soon. Get more energy. Drink a lot of water.
Hey, I'm gonna try and find that guava leaves, okay?
You better find it. You better find it. It's very healthy. You know, they say it's very healthy. You know, sometimes we look down on these remedies, but they use the same one to make this medicine. That's why I say eat veggies, eat a lot of, drink a lot of, let's say you can, if you have a blender, find a blender, always make fruit juice. Then go and buy drinks from the shop. Get your fruits, blend it every morning, whatever, different type of fruits. Eat that. Then buying drinks, whatever, alcohol, wine. I'm not saying it's bad. Everybody got their own option, but that's very healthy. You know, it's going to give a lot of protection. Remedies. Very cool. All right, no problem. Thanks so much for your time. No,
Hey,
you know.
thank you.
Okay, so please let me know when you got time so we can do this now. We're gonna do this. Let me show you what the next one. It's called integral. Integral is like a derivation of what we did. For example,
We're doing what?
it's called integration.
Integration.
Let me show you. For example, look, right? If you differentiate, what you gonna get this?
3x squared.
Yes. So for differentiation, what we do for integration, sorry, when you integrate this, you must take us back. That's the work of integration. For example, somebody say, we're not going to do like integrate is like a snake. Integrate, oh my God. Integrate 3x squared. So what you do is say, 3 is just a number. So you're going to say now, 3. And remember, for differentiation, we take to the back and then we minus. But here you add, like the reverse what we did. So we're going to say 3 just a 3. Remember, for me to get this, what happened? Because I take to the back and then I minus. So plus this one.
Okay.
So it's going to be x, 2 plus 1 equals to 3.
Okay, and then?
The same number which is here divide. You see this number here? Right at the bottom.
Oh, so that it's going to go back to where it is.
Yes!
Okay, see you in the next class. Thank you.
This one is gonna go away the snake, the integral, and they will be, yes, we operate integral. It's hard.
Hi, not too hard. We'll see when we do more exercises.
No problem. No. So that's gonna be the next one. That's the one that we submitted. That's gonna be the next one. Integration. Go. Integration. Okay. Yes. Thanks a lot for your time.
So tomorrow I'm free. Let's see. Tomorrow I'm free from 5 to 7.
Let's do the same time, 5 o'clock to 7.
See you then. Thank you so much.
No problem. Thank you too. So I will see you tomorrow then, Nos, all right? Thanks so much for coming through.
Okay, bye.
All right. Okay, bye.